Hey everyone, welcome to the lecture series on elementary classical mechanics, where we embark our journey from basic to advanced physics. Last lecture, we learned about integration and how they are used to calculate areas under the curve. Guys, this series of calculus is necessary for understanding the physical quantities, which we will derive and calculate in future lectures in physics. Integration and derivatives plays very important role in understanding physics principle. And I know and I'm repeating things, but it is important that you understand this. In this lecture you will learn about how to integrate the function and various methods to do that. So let's get started. To apply the integration on any function, you just need to put that sloppy s sign in front of the function, then plus the constant. And it is important that whenever you solve an integration of a definite integral, you should write the constant c. In the last lecture on theory of integration, you have saw that integration is the opposite of derivative. And that same is true for finding the formula for integration. We know that derivative of sin x is cos x. I will rearrange the form by shifting the dx from LHS to RHS, and same for the d. For d, while shifting it will transfer to integral sign. After writing it in a proper form, you will get integration of cos x equals to sin x plus c. Simple, right? Now we try it again for sin x. As you know from the formula that derivative of cos x is negative of sin x. Then again by rearranging, you will get the integration of sin x equals to negative of cos x plus c. Let's try something more familiar. The derivative of x raised to n is n multiplied by x raised to n minus 1, right? When we arrange it, we get the integration of x raised to n is equal to x raised to n plus 1 whole divided by n plus 1 and of course plus c. There are most of the basic function which we can do find such integral. For example, derivative of e raised to x is a raised to x. Then integration of e raised to x is e raised to x plus c constant. There are two functions. Let us consider g of x and h of x. When we apply integral on them, we can just do what we did in derivative addition rule. Integration will be applied individually to every function. So here we apply integration separately on function g of x and f of x. And it doesn't matter if we have three functions, still the integration will be applied separately on those functions. As long as they are in the sum form, this property is called as distributive property. Let us take a function of f of x equals to 2x plus e raised to x plus sine of x and find its integration. Applying the sloppy s sign on both sides, applying the integrand sign both sides. Now applying distributive property to the whole equation, we apply the formula for all three one by one. Therefore, first, integration of 2x is 2 outside and x inside the integration. We know that from the formula integration of x raised to n is x raised to n plus 1 divided by n plus 1. In our case, n is 1, so x raised to 1 plus 1 divided by 1 plus 1. So you will get x square divided by 2. But we have 2 on the outside, so 2 and 2 will get cancelled to 1 and plus c1. This is also a constant, just I taken c1. Now integration of e raised to x is e raised to x plus c2. Now the third integration of sin x is negative of cos x according to the formula of integration. Now we just recombine them. Again we get x squared plus e raised to x minus cos of x plus c1 plus c2 plus c3. Since c1, c2, c3 are constant, we can just replace it by c. The next method we are going to learn is reverse method. It is not a technical name nor it is officially used in the textbook, but in the NCERT it was used, so I am going for it. This method is worth learning. Well, most of the time before learning any other method in the integration, this method is learned as a tradition. So let us try to find the integration of function 1 by x. For that, our logic will tell us that take that x raised x to the numerator. So when it is on the denominator as x raised to 1, then it will become x raised to minus 1. That is x raised to negative of 1. Now we will apply the formula of x raised to n of integration. When we try to apply on it, x raised to negative of 1, n is negative 1, so we get x raised to negative of 1 plus 1 divided by negative of 1 plus 1, and we get x raised to 0 divided by 0. You know that any number divided by 0 is not valid. It will lead to infinity, and so it is not our answer. So you saw that we cannot use the regular method to this function, therefore we use a trick. We know that derivative of log x is 1 divided by x. As we have done previously, we shift the dx from LHS to RHS, and the small d will transfer to RHS as sloppy s sign of integration and plus c. And finally we get integration of 1 by x as log of x or logarithmic of x, and of course plus c. This is reverse method, but this is limited to simple function like this one. For far more complex form of function, we apply a different method according to the requirement. For more clarity, let us take an example. Sine of 4x. When applying the integration, we get sine of 4x as negative of cos of 4x. But this is not the correct way to do it. So we find the derivative of cos 4x, we get negative of sine 4x, and by chain rule we find the derivative of 4x separately, so we finally get negative of 4 sine of 4x. Now we arrange the dx and d, we get sine of 4x as negative of 1 by 4 multiplied by cos of 4x plus c. If we just generalize it such that, what if we find the integration of sine mx instead of sine 4x and m is any constant? Then we apply the same procedure as before. Derivative of cos mx is negative of m sine mx. Then rearranging it, we finally get integration of sine mx equals to negative of 1 divided by m cos of mx plus c. We can use this generalized term and find any integration of this kind. Here n is any constant, and just like m was before. You can verify it by yourself. Here are some quantities and you need to find the integration of those. Please pause the video and pick any one and try it out by yourself. I am sure you must have tried or you have waited me to continue. If you were unable to solve it, because there are different methods for solving this kind of function, so let's move on. Methods of integration. When solving derivative, you just need to apply the formula. If it is a product, then apply product rule. If it is form of division, then apply division rule. I mean, derivative is easy to solve compared to integration. Integration is hard, so you need methods to solve. So here we are. There are three basic methods for solving integration: substitution method, partial fraction, and integration by parts. In substitution method, we substitute one variable instead of a complex looking one, then find its derivative and do the integration. I will soon tell you. Integration by parts is like a product rule in derivative, as such that when the two functions are in the product form, you can use this method. Partial fraction is long topic and requires extra lecture to understand this, and for the basic physics it is not that used but in advance. However, if you want, please ask me in the comment section, then I will make this separate lecture on it. So let's move on to the substitution method. Let us take an example to understand substitution method. We need to find the integration of the function which I did ask you to solve, but we were unable to do it. So the function here we're going to find is integration of x sine of x squared plus 1. Let us do step by step. Step number 1. Now we take the variable t. When you tried before while solving this integration, you might be figuring it out what to do about x squared plus 1. So in that case you should substitute x squared plus 1 as t. Step number 2, find the derivative of t. Now we find the derivative of t with respect to x. So derivative of t equals to derivative of x squared plus 1. We know that x raised to n in derivative is n multiplied by x raised to n minus 1. So we get 2x and derivative of constant is 0. Now we get dt by dx equals to 2x. We rearrange in the form of dx so that we get dx equals to dt by 2x. Now in the integration form, the function is there, we write the obtained dx and substituted t. The x and x gets cancelled and you will just remain with half of integration sine of t dt. This is simple enough equation to solve now. We know that integration of sine x is negative of cos x. So we get this integration as negative of half of cos t plus c. Now you can put back the value of t earlier we assumed as x squared plus 1. So we get integration of x sine of x squared plus 1 equals to negative of half of cos of x squared plus 1 then plus c. The trick is in substitution method is that you need to know the formulas better by solving very large number of problems, not by memorizing. Memorizing will not take you too far, but by solving large number of problems. So you must know the formula better than you can work out problems better and faster. Now let us take another example just for clarity. This time we find the integration of sine of tan inverse whole divided by 1 plus x squared. This looks complicated at first, but if you know this formula, you will get pretty much idea how to solve this problem. So as before, let's substitute t equals to tan inverse. First, find its derivative. You will get dt by dx equals to 1 by 1 plus x squared. So we get dx equals to into the bracket 1 plus x squared dt. We substitute that dx in this integration form and keeping the t obviously. We can cancel the 1 plus x squared form. Finally, we remain with integration of sine t of dt. We know that integration of sine t is negative of cos t plus c, and putting the original variable in, we get the integration of sine of tan inverse whole divided by 1 plus x squared equals to negative of cos tan inverse then plus c constant. Think you got an idea how to use substitution method. Please try to solve as many as problems as you can. While dealing with physics, you will face with many formulation regarding the integration and derivative. That time, your practice will be rewarded. As I said earlier that integration by parts is like a product rule in derivative. But what I didn't say that it is a lot more complicated than product rule in derivative. But I will try to make easy for you. Let us consider two functions g of x multiplied by h of x. We need to find the integration of this product. So the formula looks like this. Now first this looks complicated, but if you look properly the pattern is repeated and that will make easy to remember. So first just write g of x then integration of h of x minus derivative of g of x and again integration of h of x, then again the whole thing after minus we integrate. Now seems a little easy, right? So I make one more attempt telling you in the manner of typed words. The first function multiplied by the integration of the second function, then minus the integration over the derivative of the first function multiplied by the integration of the second function. Let us understand by an example. Here we find the integration of x cos x. So choosing the g of x and h of x depend upon the judgment of how each function will integrate and differentiate. In this example, it is more easier to differentiate x rather than cos x. So I choose x as g of x. In this formula, g of x is left single and only we need to find its derivative. And same goes for cos x, but only this time it will be integrated faster. It all depends upon the experience you have with problem solving. So I suggest one more time that you should solve a very large number of problems. So we replace g of x as x and cos of x as h of x. Now integration of cos of x is sin of x according to the formula. Derivative of x is 1 and integration of cos x is sin x. We now get the form as x sin x minus integration of sin x dx. We know that integration of sin x is negative of cos x, so the final form we get is x sin x plus cos x. And this is how integration by parts is done. Do you know how to draw sin x? If not, try it out by taking the angle x from 0 to 180 degrees with 1/3 of difference. So you will get the graph like this. Now our aim is that I need to find the area between 0 and 180 degrees. Now we bring our definite integral into the picture. Now in definite integral, you remember that in the last lecture on theory of integration that you will integrate within the limit. That is, we can find the area under the limit of two given quantities. The pi is actually 180 degrees in radians. We find the integration of sin x within the limit of 0 and 180 degrees. We know that sin of x is negative of cos x. So we write the limit on right hand side. The method is first use the upper value to substitute in x and then use the lower value and subtract them. Seems easy, right? So we get negative of cos of 180 degrees minus, then into the bracket, negative of cos of 0. We should know that cos of 180 degrees is negative 1. So we get finally as plus 1 plus 1. And the area of sin x in the limit of 0 to 180 degrees is 2 units. So if you know the curve, it is the only matter of time and practice. We'll find the integration and then find its area under the curve within the limit. Try to find the area under the curve x squared within the limit of 0 to 2. By using the definite integral, you can find for the real valued function area under any limit. Here are we guys, end of this calculus series. You don't know how much I was waiting for this to end because just math is boring. You 99% of the audience might think so. But when you combine with the physics application, then it will be more fun and joy. In my perspective, with physics, with math is a bliss. Now in the future lectures, I will continue with the basic physics, velocity and acceleration. If you want to learn from basic to advanced physics, you can visit our playlist. Please subscribe the channel. Your gracious subscribe will encourage me to create more quality lectures in the future. Till then, stay tuned.